So this is section 2.2, which is about graphs of equations in two variables, intercepts, and symmetry. So we're going to start looking at graphing functions now. We've talked a little bit about linear equations and that kind of stuff in the last unit. Now we're actually going to be looking at graphs. Now when we graph, what we use is what's called the rectangular coordinate system, or the Cartesian coordinate system, named after René Descartes, who invented it. And it's basically created by intersecting two lines, a horizontal line, the x-axis, and a vertical line, the y-axis. So I'm going to do that right here. I'm going to draw in a horizontal line for the x-axis, and I'm going to draw in a vertical line there for the y-axis. Okay. Now, when we have that, that breaks this into four quadrants. This is quadrant 1 up here in the upper right. This is quadrant 2 over here in the upper left. Down here is quadrant 3. And then finally in the lower right is quadrant 4. Now when we plot points in these coordinates, they are given as x's and y's, where the x represents a horizontal distance. A positive x means move to the right, a negative x means move to the left, and y represents a vertical distance. So positive y means go up, negative y means go down. And so we're going to start by just plotting some points. So point A here is negative 3, 5. So that means I'm going to go left 3, 1, 2, 3, and up 5. 1, 2, 3, 4, 5. So it's going to be right up here at the top. So this is point A. Right, point B is 2, negative 4. So that's going to be right 2 and down 4. It'll be down here. Point C is 5, 0, which means we're going right 5, but we're not going up or down at all. So here is point C. Point D is negative 5, negative 3, so that's left 5 and down 3. So left 5, 1, 2, 3, 4, 5, and down 1, 2, 3. There's point D. E is 0, 4, which means we're not going left or right, we're just going up 4. 2, 3, 4. So there's E. And then lastly, point F is 0, 0, which means we're not going left or right, and we're not going up or down. So we're just going to stay right here in the middle. And this point here in the middle is called the origin. So F is located here at the origin. And so that's how we plot points. It's pretty straightforward. Now, when we have a relationship between two qualities, we call that an equation in two variables. Something like y equals 4 minus x squared. We have two different variables, y and x, and it's an equation because it has an equal sign in it. Now, solutions to these equations are any ordered pair, any x and y, that make this be a true statement, that actually make this work. And so all you have to do is take an x and a y and plug in, and you can see if it is a solution or not. And so that's what we're going to do here in example 2. It asks us to determine if the following points are solutions to 2x minus y equals 6. We have a point 2, 3 and a point 2, negative 2. So we're going to start with a point 2, 3. We're going to plug 2 in for x, and we're going to plug 3 in for y. So 2 times, we're plugging in 2 for the x, minus, we're plugging in 3 for the y, and we want to see, does that equal 6? Well, 2 times 2 is 4. 4 minus 3 is 1. So we have 1. And 1 does not equal 6. Okay? So 1 is not equal to 6. So this right here is not a solution. So we'll say 2, 3 is not a solution. Let's check the other point, 2 comma negative 2. So we're plugging in 2 for x and negative 2 for y. So 2 times 2 minus a negative 2. We want to see, does that equal 6? Now, since we have minus a negative, when we have minus a negative, that really means we're doing an addition. So I have 2 times 2 plus 2. 2 times 2 is 4, plus 2 makes 6. 6 does equal 6, so that's true. So we can say 2 comma negative 2 is a solution. Okay. So that's how we check solutions. We just plug them back in and see if they actually make the equation true or not. Now, if you plot every possible solution to an equation, then what you get is a graph of the equation. So a graph represents every possible solution. And so we're going to draw some graphs, and we're going to do this by making ourselves some tables. Before we draw these, though, I'm going to come in here and I'm going to draw in my x-axis and y-axis so that I have them. So, our directions on example 3 ask us to graph y equals 4 minus x squared, and asks us to select integers for x, starting with negative 3 and ending with positive 3. So I'm going to make a table of x's and y's, and I'm going to follow the directions and makes the x's go from negative 3 all the way up until positive 3. Now, if you have x's, to find y values, you just take these x's and you plug them in. So we're going to take negative 3 and we're going to plug it in here. Negative 3 squared is 9. 4 minus 9 is negative 5. And then we would plot that point, negative 3, negative 5. All right. Then we plug in the next x. So we're taking negative 2 and plugging it in here. Negative 2 squared is 4. 4 minus 4 is 0. So we'll plot that point right there. All right. Then we take negative 1 and we plug it in. Negative 1 squared is 1. 4 minus 1 is 3. And then we plot that point, negative 1, 3. Then we plug in 0. 0 squared is 0. 4 minus 0 is 4. We plot that point. Then we take 1 and plug it in. 1 squared is 1. 4 minus 1 is 3. And we plot that point. Then we plug in the next x. 2 squared is 4. 4 minus 4 is 0. And then we plug in the last x. We plug in the 3. 3 squared is 9. 4 minus 9 is negative 1. And so we plot that point. Now once you have a couple of points, then you can connect them together to form the graph. I'm just going to kind of connect these together the best I can. And here's the thing. We do have to put arrows at the ends because we have to imply that we can have x's that go further to the left towards negative 4 and negative 5 and negative 6, etc., etc. And we also have to have an arrow over here to continue going to the right, so that way we can go to positive 4, positive 5, positive 6, etc., etc. So we do have to put these little arrows to indicate that it does continue to go. Okay. And so there's our graph of that function. We have a similar kind of thing here for example 4. Again, I'm going to go in and draw in my axis lines first. So I can have them on there. So there's my x and y axis. We're going to make a table, just like we did in example 2, going from negative 3 all the way up to positive 3. But this time our equation is y equals absolute value of x. Now if you don't remember from previous math classes, an absolute value takes whatever number is inside of it and turns it into a positive. So when we take negative 3 and we plug it in there, absolute value of negative 3 gives us positive 3. And then we can plot that point. Take negative 2 and plug in, absolute value of negative 2, we get positive 2. That point. Take negative 1 and plug it in, absolute value of negative 1, we get positive 1. Oops, I didn't write it down there. Take 0, plug in, absolute value of 0 is 0, so we end up getting 0, 0 right there. Take 1 and plug it in, absolute value of 1 is also positive 1. Take 2 and plug it in, absolute value of 2 is 2. And then take 3 and plug in, absolute value of 3 is 3. Right there. And then we can connect them. Now, after you connect them, you do need to put arrows on the ends, again, to indicate that it continues going left and right. But it continues going to the left beyond negative 3 and to the right beyond positive 3. So we have to have it going in both directions like that. So there's our graph for number 4. Okay. Next thing we're going to talk about is intercepts. X-intercepts are the places on the graph where the graph crosses the x-axis. You can find them algebraically by plugging in 0 for y and then solving for x. Because if it's on the x-axis, the y-coordinate is always going to be 0. Y-intercepts, on the other hand, are the point where the graph crosses or intersects the y-axis. You can find a y-intercept algebraically by plugging 0 in for the x. Because if you're touching or crossing the y-axis, your x-coordinate is always going to be 0. And so we're going to do this from a graph, but we'll also do it algebraically. So our first one here asks us to identify the x and y intercepts for each of these graphs. So let's start with this one. We're going to say we have an x-intercept. Okay. Where does this cross the x-axis? It crosses right here at this point at negative 1. So our x-intercept would be the point negative 1, comma, 0. Alright. For y-intercept, we're looking for where it crosses the y-axis. This is the y-axis right here. So where does it cross? It crosses right there at 2. So the y-intercept would be 0, comma, 2. Okay, so there's this one. For our next one, okay, we're looking for x-intercept first. So we're looking for where does it cross the x-axis. It crosses the x-axis right there at 3. So my x-intercept would be 3, comma 0. For our y-intercept, we're looking for where it crosses the y-axis. And if you look at the y-axis there, it does not touch it at all. The graph is always over here. So for our y-intercept, we're going to say none. This one does not have one. Okay. Alright, last one. For this particular graph, for our x-intercept, we're looking for where it crosses or touches the x-axis. And that happens right here at the origin. So our x-intercept is 0, 0. For y-intercept, we're looking for where the graph crosses or touches the y-axis. And it crosses and touches at the origin as well, which means that the y-intercept is also 0, 0. And so it's pretty easy to get the x and y intercepts off the graph. You're just looking at where does it cross the x-axis, where does it cross the y-axis. Algebraically, it's a little bit different. To find x-intercepts, we have to make the y be 0. And to find y-intercepts, we have to make the x be 0. So let's start by finding our x-intercepts. So to do this, we're going to make the y value be 0. So we're going to fill 0 in for the y right here. So say 0 equals x squared minus 4. Now, that is a quadratic equation, and we do know how to solve it from what we learned last unit. So what we're going to do is we are going to add the 4 across. We're going to take this 4 and add it over. And so we get 4 equals, sorry, my little tablet is now acting up again. So 4 equals x squared. And then we can get rid of the square by taking the square root. And so we would get x equals plus or minus the square root of 4. And we know that the square root of 4 is 2, so this is plus or minus 2. So that means we actually have two x-intercepts, positive 2 and negative 2. When we write them as coordinates, that would be 2, 0, and negative 2, 0. So those are my x-intercepts. For y-intercept, we're going to plug in 0 for the x. So we're going to have y equals 0 squared minus 4. 0 squared is 0. 0 minus 4 is negative 4. So we only have a single y-intercept at negative 4. We would write that as a coordinate as 0, negative 4. And so there is our y-intercept. Okay. Alright. The next thing we're going to look at is symmetry. Symmetry can be done two different ways. It can be done graphically or algebraically. Graphically, all you have to do is to find symmetry with respect to the x-axis is if you have a point x comma y, look for a point x comma negative y. Because when you reflect across the x-axis, if we just kind of draw a little picture, okay. If I have a point that's up here, when I reflect across the x-axis, across this line, my point is going to go down here, and so the y value is going to change signs. So we'll get a negative y value. Algebraically, you can check if an equation is symmetric with respect to the x-axis by plugging a negative y in for all of the y's, replacing all of the y's with a negative y, and then seeing, are the equations still the same? If they are still the same, then you do have something that's symmetric with respect to the x-axis. For symmetric with respect to the y-axis, this is where you're reflecting a point across the y-axis. So if you have a point that's right here, when you reflect it across the y-axis, it'll be over here now. And so all that's going to change is the x value. The x value will change signs and will become negative x comma y. So you can just kind of look at it, look for that kind of symmetry. Now algebraically, we find y-axis symmetry by replacing all of the x's with negative x's and then seeing if the equations are still the same. The last kind of symmetry we're going to look at is symmetric with respect to the origin. This is also basically both of these symmetries, meaning that if you start with a point up here, it will reflect across the y-axis, and then it will reflect across the x-axis, and it'll end up down over here. So it kind of flipped across, diagonally across the origin. Okay. Now what that means is, because it flipped over here, the x changed signs, but then when it flipped down here, the y changed signs. So how we check it algebraically is by replacing the x's with negative x's and replacing the y's with negative y's. And that'll let us see if it is symmetric with respect to the origin. So if we're ever asked to check for symmetry, I usually try to check x-axis first, then I check y-axis, and then I check origin. I'm just going to go through it step by step. So let's look at some examples here. Start with example 7. Example 7 asks us to test y equals 4x squared over x squared plus 1 for symmetry. So I'll start by checking for x-axis. For x-axis, we are going to replace the y with a negative y. So instead of this y, I will have negative y equals 4x squared over x squared plus 1. Then we would want to solve that equation for y, which means I need to get rid of this negative. I can get rid of this negative by multiplying both sides by negative 1. So here, negative 1 times negative y gives me positive y. Over here, negative 1 times this fraction, I'm going to get negative 4x squared over x squared plus 1. Now compare that to this original equation. Are these two the same? Well, no, they're different. This one has a positive 4x squared. This one has a negative 4x squared. So because they're different, we know it's not x-axis. The next thing we'll do is we'll check y-axis. To check y-axis, we replace the x's with a negative x. So we'll have y equals 4 times negative x getting squared over negative x getting squared plus 1. And then we'll clean that up a little bit. So we'll have y equals, when you square a negative, when you take a negative x and you multiply it by a negative x, a negative times a negative gives you a positive. So negative x squared will actually come out as a positive number, and then it gets multiplied by a positive 4, so we'll end up with positive 4x squared. On the bottom, I have a negative x squared again, so it's a negative x times a negative x, so it's going to give me a positive x squared, and then I still have that plus 1 trailing behind. So that's what it looks like when we simplify. Take that, compare it to the original. Are they exactly the same? Yes, they are. They are exactly the same. So since they are exactly the same, that tells us that these are symmetric with respect to the y-axis. So I can say this is y-axis symmetry. So that's how it looks. Okay. Alright, example 8 here. I'm going to draw in my x-axis and y-axis first. Redraw them first. Redraw them again, because this is not cooperating, apparently. There we go. So there's my x and y-axis. And so it asks us to graph this equation by plotting points. And then find any intercepts algebraically, and check for symmetry. Okay, well, and it asks us to do that first. So let's actually find the intercepts first. So we'll start by finding the x-intercept. Remember, to find x-intercepts, we plug in 0 for the y and solve for x. So we have 0 equals x cubed. To get rid of a cube, you do a cube root on both sides. The cube root of 0 is still 0. And the cube root of x cubed is x. So my x-intercept is 0, 0, which is this point right there. For y-intercept, remember that we plug in 0 for the x. So we'll have y equals 0 cubed. So y equals 0 cubed, which is 0. So my y-intercept is also the origin. It is also at 0, 0. So there's still that point. Next thing we're going to do is check for symmetry. So let's check for x-axis first. So with x-axis, we change the sign on the y. So we're going to have negative y equals x cubed. And then we'd want to solve that for y, so we'd want to multiply both sides by negative 1. And so we get y equals negative x cubed. Compare that to the original. Are they the same? They're not. So we know it's not x-axis. And the next thing we're going to check is y-axis. So for y-axis, we're going to plug in a negative for the x. So we'll have y equals negative x getting cubed. If we clean that up, negative x cubed means negative x times negative x times negative x. I'm just going to write that here so you can see it. Negative x times negative x times negative x. When you multiply these two together, you're going to get a positive, because it's a negative times a negative. So it's going to be a positive x squared. But then you're multiplying it by a negative x, so you'll end up getting a negative x cubed. Take that, compare it to the original. Is it the same? No, it's not. So we know it's not y-axis. And so the last thing to check is origin. I'll draw some lines here to break this up a little bit. So for origin, you change the y to a negative y and the x to a negative x. You do both of them. So I'll have negative y equals negative x cubed. Now what I'm going to do first is I'm going to simplify this power. We know negative x cubed gives us a negative x cubed. The next thing I'm going to do is I'm going to get rid of the negative in front of the y by multiplying both sides by negative 1. Negative 1 times negative y is positive y. Negative x cubed times negative 1 gives us positive x cubed. Is this what we started with? Yeah, these two are the same. Y equals x cubed, y equals x cubed. So we know that it does have origin symmetry. Alright, so we've done the first thing it asked us to do, which was to find the intercepts and check for symmetry algebraically first. The rest of this is just going to be making a little table to help us graph this function. Now you might notice I didn't go negative 3 to 3 this time, I only went negative 2 to 2. The reason for that is when you do 3 cubed you get 27, and it's going to be way off this graph, so I didn't even bother. So if we take negative 2 and we plug it in here, negative 2 cubed, we get negative 8. 2, 3, 4, 5, 6, 7, 8, all the way down there. If we take negative 1 and we plug it into this equation, negative 1 cubed, we get negative 1. That's right there. If we take 0 and plug into this equation, 0 cubed is 0. And we actually already have that point on there because we already plotted the origin when we did our x and y intercept. If we take 1 and plug in, 1 cubed is 1. So we get this point right here. And lastly, if we take 2 and plug in for the x, 2 cubed is 8. Which is way up here. Okay. So there's our points. We'll try to connect them together. And then remember, put some arrows on the ends to indicate that it does continue going. Now this graph does have that origin symmetry. If I take this point and I reflect it across the y-axis, and then I reflect it across the x-axis, I get this point right here. So it does have that origin symmetry that we found it's supposed to have. So there is that. Alright, we got 2 more examples, right? Yep, 2 more. Same kind of thing here with example 9. Draw in my axis lines first. So it asks us to graph the equation for x equals y squared. It asks us to find its intercepts and check for symmetry first. So if we're looking for x-intercepts, we're going to plug in 0 for the y. So we'll have x equals 0 squared. 0 squared is just 0, so we get x equals 0. So we have 0, comma 0. For y-intercept, we're going to plug in 0 for the x and solve. So we have 0 equals y squared. To get rid of the square, we would do a square root on both sides. Square root of 0 is 0, and square root of y squared is y. So we get y equals 0, which tells us that our y-intercept is also the origin. So we know we're going to have that. The next thing to do is to look for our symmetry. So we're going to start by looking for x-axis. For x-axis, we replace the y's with a negative y. So we'll have x equals negative y, getting squared. So x equals, when we take a negative y and we multiply it by another negative y, a negative times a negative gives us a positive. So this is going to be a positive y getting squared. Compare that to the original. Are they the same? They are the same. So we can say that this thing has x-axis symmetry. And so now I'd like to just get a few more points. I'm going to do these a little bit differently. Instead of plugging in the x's, I'm going to plug in the y's, just because it'll be a little bit simpler. So I'm going to make the y's go, I think negative 2 to 2 is still going to be okay. So negative 2, negative 1, 0, 1, 2. So if I take this and plug it in for my y, okay, negative 2 squared is 4. So we get that point 4 comma negative 2, which is right. We take negative 1 and plug in. Negative 1 squared is 1. So fill that in there. So we have 1, negative 1, which is this point right here. If we take 0 and plug in, 0 squared is 0. So we get the origin, which we already had. If we take 1 and we plug in, 1 squared is 1. So we get a point at 1 comma 1, which is right there. And then if we take the 2 and plug in, 2 squared is 4. So we end up with 4 comma 2 as our last point. And then we would want to connect those together so that we have our complete graph. Oh, I apologize. The little tablet is still not taking. So I'm going to try drawing this with the mouse. So, there's that one. Oh, there's that one. Again, it does have that x-axis symmetry. You take whatever point is up here and you just reflect it across the x-axis and you get that point down there. So we've graphed the equation, we found the intercepts and symmetry. Then they ask us another question. It says, how does this graph compare to the graph of x equals y squared, where y is greater than or equal to 0? So it's still the same equation, but they've added this stipulation. They said that the y has to be greater than or equal to 0. So I'm just going to kind of circle this in blue. So if we did that, if we made it so that the y has to be greater than or equal to 0, am I allowed to have this point down here? No, because the y would be negative. I'm also not allowed to have this point right here. All I would get are these points right here. I would only get this part of the graph, which means I would no longer have the x-axis symmetry. I would only have the top half here. I wouldn't have the bottom half that makes it symmetrical. So it's going to be a little bit different. It's only going to have positive y values or a 0 y value. And it's not going to have that symmetry, so it's going to be a little bit different. Okay? All right, last example for this section of notes. And I'm going to come in here and draw my axis lines first. So we're asked in this example to graph the equation for 1 over x, y equals 1 over x, and to find any intercepts and check for symmetry first. So I'm still writing in blue, so let me switch back to black. So I want to look for x-intercepts first. So to find x-intercepts, I plug in 0 for y. So I have 0 equals 1 over x. Now, that is a fraction, and we learned last unit to get rid of fractions, we multiply by the common denominator. So we would multiply both sides by x. So here, on the left-hand side, we have x times 0, which is just 0. Over here on the right-hand side, 1 over x times x. That x can cancel out with that one, and so all we have left is 1. So I get a statement 0 equals 1. Is that a true statement? No, it's false. 0 does not equal 1. So what that tells us is there is no x-intercept. So we're not going to have any x-intercepts. We're not going to have any places where we cross or touch the x-axis. Alright, for y-intercept, we plug in 0 for the x. So we get y equals 1 divided by 0. Can you divide by 0? No, when you try to divide by 0, you get an undefined answer, because we're not allowed to divide by 0. So we get an undefined. So when we get that undefined, that tells us that this graph also has no y-intercept. So this graph is not going to cross or touch the x-axis, and it's not going to cross or touch the y-axis. Okay. So we've proved that. Let's look at our symmetry next. So we're going to check x-axis symmetry first by replacing the y with a negative y. So we'll have negative y equals 1 over x. And then we want to solve that for y, so if we multiply both sides by negative 1, we get y equals negative 1 over x. Is that the same thing as what we started with? No, it's not. It's not the same thing. So we know it's not x-axis. I apologize about how slow my writing is. This mouse does take me a lot to write with. So we have checked x-axis. The next thing to do is to check y-axis. For y-axis, we plug in a negative for the x. So we're going to have y equals 1 over negative x. That actually doesn't simplify. There's nothing I can do with that. So all I can do is really compare it with the original. Is it the same as the original? No, those are not the same. So we know it's not y-axis either. So the last type of symmetry that we can check is origin. So for origin, we replace the x with a negative x, and we replace the y with a negative y. So we'll have negative y equals 1 over negative x. Then we would want to solve for y, so we want to multiply both sides by a negative 1. On the left side, negative 1 times negative y gives me a positive y. Over here on the right-hand side, the negative right here could cancel out with the negative right there, and so we just end up with 1 over x. Now, is that what we started with? It sure is. So that tells us we do have origin symmetry in this graph. We should have that origin symmetry. So the last thing we're going to do is we're going to make ourselves a little table of values to help us plot this graph. And again, I'm just going to go -2 to +2 for the sake of making it fit the graph. So if I take -2 and I plug it in for x, 1 divided by -2, that's -1/2. So here at -2, I'm going to go down to -1/2 and plot a point. If I take -1 and plug it in, 1 divided by -1, I get a -1. And so I'll have a point right here. When I plug 0 in, we talked about this just a second ago, but when we plug in 0 for x, we get an undefined, meaning we're not going to have a point on the graph there. There's not going to be anything on this y-axis. Right, when we take 1 and we plug it in, 1 divided by 1 is 1. So that's this point there. And then if we take 2 and plug it in, 1 divided by 2 is 1/2. So we have 2, 1/2, and we get that point there. We could do some more points, like if we plugged in 3, we would get a third. If we plugged in 4, we would get 1/4, etc., etc. But this is okay. This gives us some points. And so what this graph is going to end up looking like is kind of like this. Something like that. Now, these are a special type of function. They are called rational functions. These functions have places in them, like right here at the x-axis and right here at the y-axis, that the graphs cannot touch. These places are called asymptotes. We'll learn a little bit more about rational functions in a later section. You can also learn more about them in future math classes. But for now, this is what we're doing with them, is just plotting some points on them and drawing our graphs. So that is it for section 2.2, graphs of equations. As always, if you have any questions, feel free to send me an email.